So today what we're looking at is double replacement reactions. So one of the reasons that I know that it's double is because if you look right here, I've got two compounds, okay? So in order to do a double replacement reaction, this is going to go here and this is going to go here. But you have to be able to determine if this reaction can take place. So the first thing I want you to do is let's go ahead and just make the products. So calcium is going to combine with nitrate. All right, I'm not just putting this here because it's what it was on this side. I'm putting this here because this is +2 and this is -1. And when you cross it, I need 2 nitrates to fix it. All right, plus Hg, which is 2, because notice this 2 had to have been up here. OH, and I need 2 of those because if this is +2 and this is -1, that's what makes that formula work. So now you've got to look. Here's one of the things that you need to make sure you understand, okay? All nitrates, anything with ammonia, anything with an alkali metal will be soluble. So I would take and write this on your paper, okay? So these are nitrates. That's what a nitrate is. This is ammonia. All right, and then your alkali metals, all right, that's what group 1 is. All right, for sulfates, this is my SO4s. For oxides, that's my O's. For sulfides, that's my S's. Hydroxide, that's OH, and carbonates and phosphates are this. Okay, so if I look, I've got a nitrate. So this one I would label AQ because right here, nitrate. It is always soluble. The next thing I have is a hydroxide. So hydroxides are insoluble. Let's see if this is an exception. Mercury is not an exception, so this would be a solid precipitate. So this reaction would take place. All right, let's look at the next one. So this is going to go here, and this is going to go here. And I'm going to write my products down below. So you're going to get NH4 oxide, so ammonium oxide, plus magnesium hydroxide. So you've got to look, first of all, NH4 is right there, ammonium. So this is going to be AQ. All right, hydroxides right here. Magnesium is not one of the exceptions, so this would be a solid. So this would both of these would occur. All right, let's try a different one. All right, so let's do one like this. Let's say I've got rubidium, phosphate, plus ammonium chloride. All right. So when I predict these, all right, this is going to go here. This is going to go here. So I'm going to do mine down here. So I'm going to get rubidium chloride, and I'm going to get ammonium phosphate. Okay. All right. Just as a reminder, this is +1. This is -3. This is where that 3 is coming. Remember, this right here is a polyatomic, so PO4 cannot change. This is +1, this is -1. That's why I don't need subscripts. All right, so rubidium is an alkali metal. So that's that group 1 right there. All right, so, sorry, I was trying to erase that. So what we're going to do, if this would be aqueous, right, because it is my group 1. So now look at ammonium phosphates. Phosphates are insoluble. unless they have an alkali metal or ammonia. So this would also be AQ. If I have two AQs, this is a non-reaction or no reaction. All right, so what I want to do is I'm going to give you a couple to try. The only way you're going to learn how to do this is to try it, okay? And I want to see if you can go through and figure out what they are. So the first one, let's do, so let's do lithium 2 carbonate plus zinc chloride. All right. And then we'll do all right. So here's the ones that I want you to do. So pause it, work them out, and then come back and see if you can get the right answer. So here's the correct answer. So remember, this is going to go here. This is going to go here. So I should get lithium chloride plus zinc carbonate. All right. Because I've got an alkali metal, this will always be aqueous. That's that rule right there. All right. Carbonates. Carbonates are insoluble. Zinc is not one of the exceptions. So this is a solid. So this reaction would take place. All right. Let's look at the next one. So the hydrogen is going to go here. Sodium is going to go here. So I'm going to get Na2S plus HCl. Now, if I look at this is a sulfide because it's just an S. It says all sulfides are insoluble unless they have a group 1, and this is a group 1, so this would be aqueous. All right. If I look here, chlorides, all chlorides are soluble. So this would also be AQ, and this would be a no reaction.